All right, hi all. Sorry I couldn't be here to give you this lesson, but I think you'll be able to learn what you need from this video. So, this unit, we're going to talk about random variables. And so let's talk about what one is. So a random variable is a variable that takes the numerical value of a chance process. Let's look at this first example. So if you flip a coin 5 times, you could get 0 heads, you could get 1, you could get 2, 3, 4, or 5 heads. And let's say x is the number of heads you get, then x is a random variable. We don't know what value it is until we flip and count the heads, but we know it's going to be one of those things, and it's going to be random. Or if you sample 10 people and ask them a question, and you want to count how many freshmen you have, the proportion of freshmen in your sample is a random variable. You could have 0.1 of your sample as freshmen, you could have 0.8. We don't know what it is, and it's random. All right, before we talk about the difference between a discrete and a continuous variable. And so discrete, again, is one where the random variable only has a countable number of possible outcomes. So that's like the flipping coins example. So if we're flipping a coin, we know that we either have 0, 1, 2, 3, 4, or 5 heads. Can't be anything else, and yeah, we can count those. And then a continuous one are things like height, weight, because those, if we measure something, it could be like 50 feet or 52 or 51.6 feet, etc. You can continuously dig more and more and get smaller and smaller measurements. All right, so now let's look at example 1. Here we have 3 different random variables, and we have to figure out which of them are discrete and which of them are continuous. So pause the video, take a few minutes to try to answer the question, and when you're done, unpause it, and then I'll go over the answers. All right, let's see. So let's see. Bulbasaur is walking through a patch of grass. X is a number of Pokemon. Well, you can't have hopefully you don't have half a Pokemon or a part of a Pokemon. So yeah, we can't continuously divide the number of Pokemon we have smaller and smaller. So here we have a discrete random variable. For part B, let's see. Here we're talking about the mean volume. So volume it's like a measurement, and so if we have, let's say we have 20 ounce bottles, it could be 20 ounces, it could be 20.1, could be 20.126. We can always dig further and further and smaller divisions. So in this case, this one's continuous. And then finally, if we roll a die, this is the number of times something happens. Number of times should be discrete. Like we're not going to show, it's not going to take, say, 2.5 rolls for a 6 to show. It's either going to be 2 rolls or it's going to be 6 rolls. So this one's discrete. Okay, let's do some review about probability distribution. This one's a little hard, so you don't have to pause. I'll go over it with you. If you want a challenge and you want to try to answer the question on your own, feel free to, and then unpause when you're ready to go over the solution. All right, so probability distribution. A good way to represent a probability distribution is in a table. And so X is the number of heads. And then here, we're going to talk about what's a probability of getting X. The next step should be for you to try to figure out what are the different values of X you can have. And again, X represents the number of heads. So when you're trying to figure out what X can be, you're trying to figure out how many different numbers of heads can you get. So, okay, we're flipping 4 coins. We could get 1 or 2 or 3 or 4 heads. But remember, you can also get 0. Students often forget 0, whatever, so make sure you include it. All right, some of these probabilities you should be able to calculate already. For the 0 heads, that means all 4 flips were tails. So the probability of that should be 1/2 to the 4th, 1/16. And for the 4 heads, that means all 4 were heads, each with a probability of 1/2. And so this should be 1/2 to the 4th. The other probabilities are a little bit more difficult. So what we should do is try to dig in more deeply to figure out what's going on. Let's say we want to figure out what's the probability that x is 1. That means we have 1 head. One way that can occur is we could have heads, tails, tails, tails. But that's not the only way, right? We could have heads on the second coin flip, or the third, or the 4th. So it turns out there are 4 ways to get 1 head, 4 ways out of 16. If you try to do the same thing for 3 heads, you'll get something very similar. Instead of trying to figure out where we can put the 1 head, here we're going to try to figure out how many different ways can we place the 1 tail. And again, there are 4 ways. So the probability is still 4 out of 16. For 2, it's a little bit more difficult, but you just have to be very methodic about how you write things out. So again, each of the outcomes here will have 2 heads. So don't just copy them down. Try to think how we're going to write these out to make sure we don't double count and don't miss anything. So one way to do it is start with all the heads on the left and then try to slowly move them over to the right. Or you can talk about, let's just keep the first one heads, and then make the first flip tails. And we have our 6. Okay, we have all the probabilities, and one way we can double check to make sure we did it correctly is all of these probabilities added up together should have a sum of 1. All right, let's move on to the next page. All right, sometimes we want to calculate the mean of a random variable. That's what we expect the value to be. And so sometimes you'll see that the mean of a random variable is called the expected value of it. So here's a complicated formula. E of x, this means expected value of our random variable x. And the way we calculate it is we take each value, so like say x1, and then multiply it by the probability of it happening, p1. And then we do that for the second outcome. What's the value of the outcome times the probability it happens? Go all the way through, multiply them all together, and then add them all up. And if you want some fancy notation, you can use this over here. So again, here are the instructions. Multiply each value of the variable by the probability of it happening, and then add up all your products. So sometimes you can use this to make decisions. Like if once you're done with this section, you go to a fundraiser or whatever, there's some raffle where the expected value is $4, then you might think it's worth it to buy a raffle ticket if the tickets are less than $4, right? If the raffle tickets cost $3 each and you think you can win $4 on average, then yeah, you on average will end up ahead. On the other hand, if the tickets are $5, then maybe you don't want to. All right, let's go back to the flipping 4 coins example. And let's say we're trying to figure out the expected value of the number of heads we get. Okay, so I'll reproduce the table here so that we remember what we had. possible number of heads were 0, 1, 2, 3, and 4. The probabilities were 1/16, 1/4, 3/8, 1/4, and 1/16. All right, our formula. So again, the procedure says multiply each value by the multiply each value by the probability that you get that value. So for the first one here, the value is 0, the probability is 1/16. We'll multiply them together. For the second one, the value is 1, the probability is 1/4. And then just go all the way through. And if we do this correctly, we should get 2. And intuitively, that kind of makes sense. If we flip 4 coins and the probability of getting heads is half, then half of our 4 flips on average should be heads, and that's 2. All right. Sometimes we're also interested in spread. So for spread, this makes things a little bit more complicated. So for spread, what we have to do is, well, usually we're going to use variance and standard deviation. And so the first thing we'll do is we'll come up with the variance, and then remember that to find standard deviation, well, you just take the square root of the variance. All right, so let's talk about how to calculate the variance. Here's a formula. What we're going to do is we're going to take each value, this is a value, and then subtract the mean. We're going to square the difference and then multiply that by the probability of that value. So again, take each value minus the mean, square the difference, multiply by the probability. And then once you do all that, add everything up. All right, let's see this in play. So here, we're going to do the 4 coins again. So the variance is going to be, you can use the table above in example 3 here. Right here. All right, so again, we take each value, so 0 minus the mean, square the difference, multiply by the probability of that value. And add it to the next value, minus the mean, square the difference, multiply by the probability. And just go all the way through. All right, take a moment and write out the rest of the line, and then I'll do that for you. All right, again, the next value is 3, minus the mean, square the difference, multiply by the probability. Add value minus the mean, square the difference, probability. And this mean, this 2 that keeps showing up, that's a mean from up here, right? This is our expected value, or our mean. And that's why we have 2s all the way here. There's one here, this one, this one, this one, this one. All right, bust out your calculators, calculate it, and let's see what we get. If I'm not mistaken, we get a variance of 1. Let's double check. Yeah, I'm pretty sure we're good. All right. Ooh. We need the standard deviation. Well, in this case, if you forgot to calculate the standard deviation, you would have gotten lucky because the standard deviation is the square root of the variance, and that's just still 1. All right, next page. All right, so here, craps again. Sorry if this is triggering for you. All right, so let's see. Here we're told we either win or lose. Those are the only two possibilities. Here's a probability of winning. If you want, put a little note. And let's see. If we win $5. If we lose $5. Let's say X is how much we gain All right, and we have to find the mean and standard deviation. All right, again, even if you're not asked to, I would summarize everything in a table. Like, you don't want to have to go back and read the problem and figure out what information is where. Summarize it in a table. There are only two outcomes. We either win or we lose. If we win, we gain $5. If we lose $5. Losing $5 means negative $5. All right. So now, the probability we win is 244 or 495. Probability we lose should be 1 minus that, which we can get from our calculator. All right, the mean or the expected value. Take each value, multiply by the probability of getting that value. And we get looks like the calculator gives us negative 0.0707. But this is just how much we're going to win or lose in dollars, so make sure you put units. So what this means is, on average, every $5 bet will result in us losing about 7 cents. All right. For the variance, we're going to take each value minus the mean. The mean is negative 0.0707. Square the difference, multiply by the probability. Add that to the other one, negative 5 minus negative 0.0707. Square the difference, multiply by the probability. And then use your calculator. So I get a variance of just about 24.995. And then from there, the standard deviation should just be the square root of that, which is basically, we'll go with 5. All right. All right, Number 6. So here we're looking at what are called APGAR scores. It's a score that's given basically, I think it's either 1 minute and 5 minutes after a baby is born. It's there to try to figure out how healthy the baby is. If you want, you can look it up. I forget what the letters stand for. I think it's like appearance, pulse, grimace, agitation, and respirations. Look it up if you want. All right, so here, let's start with the part A. We need to find the probability that the newborn will have a score of 8 or higher. 8 or higher, just add those numbers. Let's see, I get 0.809. All right, for expected value, again, we're going to take each value each value multiplied by the probability of it occurring. Now, if you don't want to write out all 11 numbers here, that's fine. Just put a little dot, 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 and then put the last number. There's a lot of typing. If you want, when I come back, I can show you a shortcut that makes these calculations a little faster. It's something you'll have to program in your calculator, but it's pretty cool. So when I'm back, if you want to know it, ask me and I will show you. I get 8.128. All right, for the interpretation, then just say what the average score is going to be. So on average, a newborn will have an APGAR score
This week's advisory is for all freshmen and juniors. Seniors, please head to the football field bleachers immediately after 6th period for the senior panoramic photo. The photo shoot will be at 2 p.m. Thank you.
All right, an APGAR score of 8.128. All right, next, find and interpret the standard deviation. So again, to show work, let's find the variance. So that's each value minus the mean, square the difference, multiply by the probability. Skip a few, value minus the mean, square the difference, multiply by the probability. All right, take some time, calculate that, and then unpause and we'll go over the answer. see, I get 2.0656. The standard deviation should be the square root of that. And so the interpretation is, on average, an APGAR score will differ from the mean by 1.437. All right, finally, we're going to talk about continuous random variables. So here, remember that the area under the density curve always has to be 1. And since this is a triangle, the area is 1/2 times the base times the height. And that has to equal 1. As a result, A should be 1/2. For part B, if we want to find this probability, we need to find the area under the curve. The area under the curve between 1 and 2. So here we have, well, different ways you can do it, but this is a trapezoid. So one way we can find the area is 1/2 times the base. The base is here. Sorry, the base is here. Oh, we don't know what that is yet. Oh, okay, maybe we shouldn't do this way. Oh, well, we still need to find this somehow. Need to find that. So, well, let's see. This is 1/2. Then the slope here that's going to be the 1/8 or -1/8, which means every time we go down here, we go down by 1/8. And if we go down by 1/8, then this here, this should be 1/2 minus 1/8, which is 3/8. Do it again, this is gonna be 1/4. So yeah, we can use the trapezoid method. 1/2 times the first base plus the second base times the height, which is 1 here. .3125. And then finally, the only difference between parts B and C are these equal to parts, but the probability of getting exactly one number should be 0, and so the answer should still be the same. All right, if you have any questions, I'll be back, and feel free to ask me them then.